Hey guys, the question would like to know which one of the following would be expected to have the highest boiling point. Okay, so let's talk about boiling point for a second. If you have a certain compound, okay, and it's a liquid, right? Because boiling is the transition from liquid to gas. Okay, so you have this liquid, and basically what's going on is all those molecules, right? And we're assuming it's a pure compound here, right? So it's going to be all, let's call it compound A, just for the sake of the analogy, or for the example. And so you'll have all these A molecules floating around, right? And these A molecules will kind of interact with one another, whether it's water or whatever it is. They will exert forces on one another. Sometimes it'll be attraction, sometimes it'll be, sometimes it'll be repulsions, but they're gonna affect one another. And basically, without going into too long of a story here, basically is you want compounds that are, for strong interactions, you want compounds that have sort of really negative and really positive sides. In other words, you want dipoles. So for example, something like butane will have a very low boiling point. Why? Because it's the electrons are very evenly spread in a butane molecule. So there's no partial positive or partial negative sides. You see what I'm saying? So the two butane molecules will only have London dispersion or van der Waals forces. So the interactions will be very, very weak. And so therefore, it'll be very easy for one butane molecule to kind of break away from the rest of the group and go into the gas phase. And so therefore, the boiling point for butane is very low. However, if you have something like water, right? Remember, water can make these hydrogen bonding networks. And so therefore the water molecules are kind of holding on to each other very, very strongly because these hydrogen bonds are very strong. So therefore it's actually very difficult for one water molecule to break away from the group and go into the gas phase. And as a result, you have to add a lot of energy. And that energy, remember, that energy translates into sort of their kinetic motion, and the molecules will start moving faster. And in the process, eventually what will happen is one of them will break away because it's just moving so fast that it overcomes these strong forces of attraction between the molecules. Okay? Very exciting stuff. All right, so basically, if you look at these compounds, obviously E is going to be out because E has no hydrogen bonding, right? E is very sort of almost a non-polar compound, so therefore E is going to be a very low boiling point. But if you look at A, B, C, and D, you'll see it's kind of very tricky. We have alcohols, amines, and another phenol. And already that kind of tells me that C and D will probably be out because both of them have alcohols, and alcohols kind of act similarly. Now, yes, definitely a phenol is going to be very different from a regular alcohol because those lone pairs will kind of get pulled into that tornado of electrons spinning in the ring. So it won't be quite the same. But the correct answer, just looking at this, we can actually already see is B because of the carboxylic acids. You see, carboxylic acids form these incredibly strong hydrogen bonding networks. And so basically what you have is you have these dimers. So the hydrogen of one carboxylic acid hydrogen bonds to the carbonyl of the other carboxylic acid molecule, and vice versa. You see, so this hydrogen here will hydrogen bond to this carbonyl's lone pair, and the hydrogen on this one will hydrogen bond to this lone pair on this carbonyl. And as a result, these dimers are incredibly stable, and as a result, it will be very difficult to break these molecules away from one another, and as a result, these carboxylic acids have very high boiling points. Okay, so therefore the correct answer is going to be answer choice B, even though A, C, and D can all form hydrogen bonds, will all experience hydrogen bonding between the various molecules as well. If you have any questions on this, feel free to shoot us an email, but this is just something that you should memorize. Just remember that carboxylic acids form dimers. You can even see it in something like, they're even so strong that when you take a carboxylic acid and you run it through mass spec, right? And let's say you expect the molecule to, let's say, have an atomic mass of, let's say, 150, hypothetically speaking. A lot of times what you'll see in the mass spectrum is you'll see a massive peak, a very strong peak at around 300. And that's the dimerization of the carboxylic acids that cause that. The two carboxylic acids are bonded so strongly that they are read by the mass spec as one compound weighing basically twice as the original carboxylic acid compound. Okay, so make sure you guys remember that these carboxylic acids form dimers and therefore have very high boiling points. So the correct answer here is going to be B. Thank you so much for watching, guys. If you have any questions, feel free to shoot me an email. I'd be happy to explain things in more detail. Have a nice day.